So my name is Justin Kursov, and I'm going to be presenting this Fuzz for All paper. This is a very interesting paper right here because fuzzing is something that we need to create a special program for every single new language that you're trying to use. There are many different methods of generating random input data so that you could test a bunch of different software for security issues, try to make a language crash. And so with what they did is create something that's universal that can target many different inputs. And the cool thing is it uses LLMs in order to do that. So that's just another thing that you could do with LLMs. So for some context, I just introduced what fuzzing was. You have a couple of problems though, because you have a certain language that it's built for. It's not good for evolution. Usually when you generate prompts for the input data, it's not that good and it kind of loses its vigor after a little while. And so they're using an LLM. So they're trying to solve this gap, and they're using an LLM as an input for the fuzzer, and not only that, but to generate actual prompts and snippets of code in order to do that. And so this is such a cool thing because now you can create fuzzing engines for many different languages and bring them all together and start fuzzing C, C++, Java. You could start fuzzing all sorts of different code examples. So part of their method, go to this diagram right here so I could show you. So they use a LLM chain. First, you take a sample code and their prompts are put into an LLM, which creates some sample prompts, which kind of tells the next generation LLM what kind of code it's trying to break based on the sample. And so it creates these code snippets, which is then scored by another LLM, and then it picks out the best prompt. And then that again goes to the next chain, and then it has this prompt that this generation LLM is going to start making fuzzing inputs. And then it's gonna select the best code snippet. So again, there's that process of taking and then diminishing how many and creating like an argmax for those prompts. And then there's three options that can happen after that. They could either make a new prompt, mutate that one, or make some kind of equivalent to that. And then it'll create a prompt. And so this is going in the background while these inputs are actually going into this language. And so you can see that this is a brand new way of fuzzing and creating new prompts and inputs that are going to be testing these different languages. And so there's that auto prompting result. So that's more of the same. And right here, you could see the system under test that they had. They were testing it with GCC, Plang, Go, Java, and then they compared it against different fuzzers. And their key results was that over time, they actually were able to get a lot more things out of the fuzzer. So usually if you use a fuzzer, it starts doing random things and it uses some kind of algorithm to have sample inputs. And after a certain amount of hours, it starts to flatten out and you don't really get that much more coverage. However, if you use their technique, you actually get a lot more coverage because you have you have LLMs constantly churning input data and looking at new coverage, and so you get these lines that go up. And so that is an insane improvement right there. Over 75% for QSKit. And then there's some other metrics that we have for fuzzing, which is how much more coverage there is for every single fuzzing based on keywords or functions and theories. And so this is also nice to look at because now I kind of understand a little bit more about what you would be looking for when you're fuzzing and the amount of coverage is. And so in summary, they were able to find 98 total vulnerabilities, and 64 of those were confirmed as unknown. And so that's a great improvement for overall security of that language. And these are examples that cause segmentation faults and crashes. And the next steps, they talk about how they want to continue developing and refining the fuzzer, integrating more advanced LLMs, expanding its capabilities, and include more languages. And I think that they could explore integrating this fuzzer within development environments as a standard testing tool. So that'll be pretty cool, especially for new, niche, and upcoming languages. And I think this paper is great for security and using language models. And thank you for your time.